want to show an example of how you would use this sheet to make your I/O wiring diagram for your simulator and your programs. The I/O wiring diagram stands for input-output wire diagram, and it shows how the actual devices, the field devices, are connected to memory locations inside of the PLC through addressing. So if you take a look at this brief example that I made, I have a very simple hardwired control circuit consisting of a single pole, single throw switch that we use as an on switch. And remember, when you close a single pole, single throw switch, it'll stay closed until you open it. You have to physically move the pole. And then we have a normally open push button. And remember, that works like a doorbell, normally open, so it's only closed. It has to have some kind of human actor or some kind of actor to actually physically close the contact, but when you release it, it opens up. So we call this the pulse on. Also note my power lines. This is line 1 and line 2. And we mentioned in class before, you can think of current as just flowing from left to right in the hardwired circuit. Below I have the logic program to implement this circuit. So we use the examine if closed instruction, and we use another examine if closed instruction, and then we have our output energized to represent the red lamp and the green lamp. So how would you show that in your I/O wiring diagram? Well, basically the lines, the power lines, go back here. So that those power lines are represented by these two outside lines. So this is like your L1, and this is like your L2. That represents your power line. And then here, these are the side rails for your rungs. So you actually go in and you show you kind of hand draw your instructions in here that you use to implement the hardwired circuit. So you might have a rung like this. And then this space over here, and this space over here, this is where you show your connection information. So you're actually going to tie the physical field device to an address. So we have the hardwired circuit, we have the logic circuit or logic program to implement it. But then my I/O diagram, outside here, those line 1 and line 2 that we referred to, I show a physical connection for the single pole, single throw, and for the normally open push button. I show a single connection to line 1. Then I have this address box, and then there I want to show the address that I'm going to use for that particular instruction. You do not want to show a connection between the address box and the side of the ladder rung. There's no physical connection. Everything inside of here is virtual. This is inside of memory. And out here is the hardware for your input and output. So the output circuit is the same. Notice I have my actual field devices I'm using from the hardwire diagram and the correct symbols for them. And again, there's no connection between the address box and the side rail of the ladder rung. So if you look at the solution, let's see, let me upload that real quick. I think I might have uploaded the solution. Your final diagram for this simple control circuit might look something like this. So it's pretty simple to do, and you'll include this with definitely with Lab 1, and then with some of your other programs, you'll have to include this I/O wiring diagram. This is actually pretty important, and so I'll have a little bit more to say about this when we meet face to face, but this should be enough to get you through the lab that you're doing right now. Thank you, and we'll see you soon.